So how does the force change, the gravitational force, with respect to the distance that an object is from Earth? So here we have this rocket at a distance of 1 Earth radius, and the force, they say arbitrary units here, is 1 arbitrary unit. We could call it also in newtons or in pounds. We could also call it the acceleration due to gravity. So the 1 here therefore would then correspond to 9.8 or around at 10. Okay, so let's take the rocket out to 2 Earth radii, and you can see that down here, and right there I got it. So at 2 Earth radii, because of the inverse square law, I would square that. So 2 squared is 4, and notice what happened to the force. It's 1/4 of what it originally was. That also means that the acceleration is 1/4 of what it was. So 2.5 in that case for the acceleration due to gravity. Notice that's also shown here on the graph, which is approximately, it shows like 2.5. Okay, when I take it out to 3 times, we can see that the Earth's radius, or the distance, is now 3 times the Earth's radius. I don't think I'm ever going to get it exactly on there, so this is around at 3.0. There's around at 3.00, 3.01, and that means that the distance squared is 9, and therefore the force is 1/9, and when you look at that, 0.11 is 1/9, or the acceleration due to gravity would be 1.1. At 4, of course, I would have 4 squared is 16. That means that the force is 1/16, or the acceleration due to gravity is 0.6. So always square this ratio down here, which is the distance to the Earth's radius, and then divide that into 1, and you come up with the force in arbitrary units, or the acceleration due to gravity. Okay, what about fractions? Well, let's say, how about 2.5? 2.4. Well, square the 2.4. That's, I do this on the side here, 5.76. And then divide 5.76 into 1, and you come up with 0.17, exactly what it says respectively for the acceleration due to gravity. It would be 1.7. Okay, what about fractions over here? Let's say I'm going to try here for 1.05. Let's see how close I get. So 1.05, and I square 1.05. and that gives me 1.10, and then I divide that into 1, and I come up with 0.91, exactly what it says here, respectively for the acceleration due to gravity, 9.1 meters per second squared. There's another thing here. If it's very close to 1 itself, to 1.00 itself, take that 5, double it, which is 10, and subtract it from 1. So respectively double it, which is 0.1, and subtract that from 1, which is 0.9. Notice that it's relatively close. Notice that for 1.03, if I'm able to do that, there, right there, double the 0.03, which is 0.06, subtract it from 1, you come out with 0.94. So these are ways to do a kind of problem where you have the distance in relation to the Earth's radius. So this is a fraction here. The distance is 1.03 times the Earth's radius, and figure out what the force is, respectively the acceleration due to gravity.